TensorFlow ROS Train is a unique ROS package that seamlessly integrates ROS data collection and TensorFlow model training. Incredibly rapid model interfacing is made possible. A typical user will first define a function creating any TensorFlow model. They can then specify any data that they plan to collect using a ROS reading. This is a custom ROS data wrapper class specialized for being an input to a model. The user specifies appropriate data names, message types, and which topic to subscribe to for obtaining this data. Now, the user can create a ROS model, a wrapper around the TensorFlow model. Features and targets are specified using ROS readings. The user can now take advantage of convenient methods such as collect data. Let's see what this short script is able to accomplish.
The script is run. Upon manually starting a simulation, a custom CSV file is generated that contains the features and targets of the model. No manual message subscription or data extraction is necessary.
ROS Train also provides convenient automation of simulations to collect data. The user may create a ROS task to describe a scenario to collect data in. For example, the user may make a ROS task named TurtleSimNav that allows a turtle to navigate to a random goal using a PID controller. The user can then specify to collect data from 1,000 of these tasks. In the future, the user will also be able to specify if they want the model to be trained online, simultaneously with the data collection.
Let's see what this looks like. Here, the user specifies 5 default TurtleSim tasks. The simulation is automatically started, and data is collected throughout. For each task, the turtle is given a random goal location and quickly navigates using a PID loop.
Training alongside ROS is very convenient. The user specifies collected data through either a collect data method or a path to a CSV file. They can then fit the model to this data using only this reference. This is possible because the ROS model contains fields specifying which data it wants, so only these will be extracted from the file. Of course, there are plenty of more complex situations that warrant more user control. Take a look at this model. Something like angular deviation would need to be calculated rather than simply subscribed to. The user can specify custom feature and target processing and then fit the model using these functions. More importantly, the core TensorFlow model can always be made visible with ROS model.model, so any TensorFlow or Keras method is still applicable. This package will be open source. I have plans to expand its functionality and get ROS community support for generation of public data repositories, pre-trained models, and engaging tutorials to help open up the world of autonomous navigation to everyone. I hope that this package will be a great help to both newcomers and experienced researchers alike.